Okay, this is a continuation of section 2.2 for MAC 1105. We were in the process of graphing a piecewise function. We had decided to anchor into the wall x equal to 3 with an open circle because there's no equal sign here. And now we're about to pick values for the graph that is over here on the left where all x values are less than 3. So we need to be picking values that are less than 3. So next thing I'm going to pick for the function in this area x less than 3, which is f of x equal to 1/2 x squared, a parabola. I'm going to keep plugging into that. So now I'm going to go less than 3. I'm going to pick 2, then 1, then some negatives. I'm going to pick 2. This will be 1/2. I'm plugging 2 in here. I'm squaring it just like the function says. So this will be 4 divided by 2, which is 2. And I guess I should write that out just so nobody's getting confused. It's 1/2 times the 2 squared, which is 4, which is the same thing as 4 divided by 2, which is 2. So that I'll be plotting 2, 2 for that point. So 2, go up, 1, 2, plot that point. The rest of the points can be solid. It's just at the wall I had to make a point that was open because of not having an equal sign. You could also plug in 0. You could plug in 1. If I was to plug in 1, which is all values less than 3, and square it, that would be 1 times 1/2 would be 1/2. So I'd have the point when plugging in 1, I get a 1/2. And that would be right there. And then if you plugged in a 0, you would be 1/2 of 0 squared. That would be 0 times 1/2 is 0. So you would also have a point at the origin. And you know this is a parabolic shape. It's just not a full parabola. It's a piece of a parabola. So it should be going up now. So try a couple of numbers over here. If you were going to plug in -1, then it would be 1/2 times -1 squared. That would be 1 times 1/2 is 1/2. So you'd be plugging in -1, 1/2. -1, and then 1/2. And then if you were to plug in -2, it would be 1/2 times -2 squared. That would be 4 times 1/2 is 2. So you'd be plugging in -2, 2, -2, 1, 2, and there you go. It's starting to climb up to give you that parabolic shape. Okay, so on one side of the graph, we have this parabola that gets cut off right at the wall. Over on the other side, where the x values are greater than 3, we're using a different piece of a function. This is a 2-piece function. So wherever x is greater than or equal to 3, we're going to be using 5x minus 9. Oops. 5x minus 9. So we'll always be plugging it into that if we want to. Now on that side, you're going to have a straight line. There's no second degrees or anything like that. So if you wanted to plug in first start by anchoring into the wall by actually using 3. This time it'll be a solid point because of this equal sign. So if you were going to plug in the number 1 there, maybe we can do this a little bit mentally because we're running out of room here. If we were going to plug in, let's start with 3. So we can hook right into this wall. 5 times 3 would be 15. 15 minus 9 would be 6. Okay, if you plug in 3, 15 minus 9 would be 6. So we can plug in, we can plot 3, 6. So 3, go all the way up to 6. And that's right there. We're beginning to graph the graph that's over here on the right-hand side. If we're going to plug in something like 4, that would be 5 times 4 is 20. 20 take away 9 would be 11. And for a straight line, you really only need 2 points. So at 4, which is 4 right here, you're going to be shooting way up to 11. Let's just call it like that. You already know it's a straight line because anything where the x's are first degree, all the x's are first degree, and you have y that's first degree. That's a straight line, slanted line. So we have this graph on the right side of the wall called x equal to 3, and we have a different kind of a graph on the left side of the wall, and that's called a piecewise graph. Okay, moving on to the next page of section 2.2. Last thing we have in this section is what's called the difference quotient, and there is a very heavy application for this particular concept as you go on in your math classes. Depending on how high you're going to go, you'll see how it is used in various capacities. So in this particular class, we just want to see if you can calculate the difference quotient for a function. Geometrically, it is described as the slope of the secant line. A secant line is when you take 2 points that are on a curve. This is the curve. Here are the 2 points, and the line that goes through it is called a secant line. Well, when you find the difference quotient, you are finding the slope of the secant line. Okay, so this is the function that we're going to be using right here. And we're going to follow this formula, this procedure for finding the difference quotient. If you were in various math classes that were higher than this, then you'd be finding that a different way. So many applications for this difference quotient. Okay, so let's start with what does this mean? This says take your function. This is your function right here. That's just the name of it. This is where you'll actually be doing your work. You're going to do this, and then you're going to divide by h. So you're following this to find the difference quotient. This says at first you should plug in x plus h wherever you see an x. Then you should use just the original function and subtract it from whatever you got here. So first let's do f of x plus h. Where everywhere there was an x, we're going to plug in this entire expression x plus h in parentheses. So here we go. Only place there is to plug in is right there where there's an x. So leave a blank spot where there's an x and copy the minus 3. We're trying to do the portion where we're doing the function, 5x minus 3, but with an x plus h plugged in. Then we're going to subtract, and when you're subtracting anything that has more than one term, such as this, you need to close it off with parentheses, so you'll remember to switch all the signs. This says now subtract the original function, 5x minus 3. Finally, divide by h. Okay, so all we've done so far is use the recipe that the formula gives us for finding a difference quotient. And now we're going to simplify it. We have everything plugged in. We plugged in an x plus h into this 5x minus 3. Then we subtracted the original function, as this says, and divided by h. Now simplifying, we have 5 times x plus 5 times h minus 3. Then we're going to switch the sign of this 5x as well as the negative 3. That is what that minus sign means. And we're going to be dividing by h. We're going to look at terms that cancel, such as the 3's and the 5x's, leaving us with just 5h in the numerator and h in the denominator. Noticing that the h's cancel and the answer for our difference quotient is 5. Okay, 3's canceled, the x's canceled, and we were left with 5h divided by h. H is canceled, we're left with 5. So that is the answer for the difference quotient. And that completes section 2.2.